Hello everyone. In this video I'm going to be going over how to graph piecewise functions. This is the example that we covered in class, just so you have another reference to refer back to when you're completing some piecewise function questions. So in this case we're given three actual functions that compose, or three separate rules let's call them, that compose f of x. We have 5, just the horizontal line where the output y is always equal to 5. We have the rule half x minus 6, and we have the rule negative 2x plus 10. Now remember, on the right-hand side are the given intervals. This is basically saying where each of these three rules is defined, or where each of these three rules actually works. Now what I like to do to start this is to make our mini tables. So in this case, being that we have three rules, I'm going to put together three mini tables for each rule. I also like to kind of give each one its title. This way I could see clearly which one is which. And remember, even though that all three of these are lines or line segments, we don't want to really rely on M and B strategies. While these can be used, it's actually more efficient due to the open and closed circles, due to it not necessarily always hitting the y-axis. It's more efficient to actually use tables. Okay. So let's start with 5. For the rule 5, 5 is defined at everything less than negative 2. So this means we actually want to include negative 2 in our table. That's the largest value that, the largest x value that is allowed here, negative 2. And I'm going to choose a few more smaller than that. This one doesn't have a left side restriction. When I say left side, like going to negative infinity, it doesn't have a restriction. It's going to go on forever. So I'm just going to choose a few more values less than negative 2. The outputs are very simple here. The output is always 5. That's why this is a horizontal line again. And now next to the table, I make a little annotation in terms of what I should see there. At negative 2, I'm going to see an open circle. Why? Because negative 2 itself is not included. Now, we said this does go on forever, so I'm going to indicate that with an arrow on the left-hand side. What a lot of people do here by mistake is kind of put the arrow going in the other direction. So they'll put like negative 2, negative 1, 0. So the line's like going to the right-hand side. But remember, this segment is only defined at everything less than negative 2. Okay, for half x minus 6, I have this sandwiched inequality. In some cases, this is actually more simple because we know exactly where it starts and exactly where it stops. So I'm just going to put those two values. I'm only allowed to do this for line segments because I know exactly what happens between these two endpoints. I just need to plot them and connect them. Obviously, if this was a curve or any other type of graph, I would not be able to do this. To find the outputs, I could simply use my calculator or just using some mental math here, plug in these x values into the rule. For example, half of negative 2 would be negative 1, minus 6 would be negative 7. Half of 6 is 3, minus 6 is negative 3. These are both going to have normal endpoints, closed circles, whatever you like to call them. Excuse me. Because each of these values is included. And for our last rule is defined where x is greater than 6. So we're going to put 6 in our table. Remember, we've talked about this error of like rounding up. So like using 7 by mistake. We're very simply just going to use 6 still, but we're going to use an open circle. So just because a value isn't included doesn't mean you shouldn't see it in your table. And now once again, kind of similar to the first rule, this one doesn't have a right-hand side restriction. So for this one, I'm just going to choose a few more. You could get away with even just doing 1. I'm going to do like 7 and 8. Okay. Once again, similar to the last table, we actually have to plug in here or use a calculator or something to figure out the outputs. So when you plug in a 6, you'll get negative 2. When you plug in a 7, you'll get negative 4, and so forth. And this goes on forever this way. So this is all the setup. So I have my tables. I know where I'm making arrows, where I'm making open, where I'm making closed circles. And now all I have to do is plot the points. I kind of do each part separately. You don't want to just start plotting everything together. So like we'll do the first table, kind of finish it off, move to the second table. All right, so negative 4, 5. This is just a horizontal line, so this one is pretty simple. And at -2, when you make an open circle, kind of like circle that point. You don't have to make it like massive or too exaggerated, but you do want to make sure it's clear that it's not a regular point, a regular dot. For half x minus 6, I'm going to plot -2, -7. And I'm going to connect those. Those are both normal, closed circles. I usually make them like a little bit bigger than a normal point, just so you can see it. And then 6, -2 is open. Circle that point. And then you can even cheat a little bit and like use the slope. So like I see the slope of that line is -2. Once I plot that point, I could do something like go down 2/1. That's what I meant in the very beginning. Like you can still use some M and B ideas even though we're not really using it. Okay, arrow on the end because this isn't restricted. And now let's just talk about the intervals again, because like I said, this is where people tend to make mistakes. For the first function, for whatever reason, people like to like put an arrow on like going the wrong way. Um, so analyzing each part here, x is defined, this function is defined when x is less than -2. That works here, right? Everything less than -2, this rule applies. Everything between -2 and 6, that middle function applied, and everything greater than 6, not including 6, is that third and final function. So as you kind of go from left to right, you could see the whole story kind of laid out in front of you. This is still a function. Even though it looks like it would fail the vertical line test, we have kind of like an open and a closed every time it looks like they're sharing an x value. So that sums up the strategy for graphing piecewise functions. Using mini tables, making your little annotations, choosing which values to have in your table, and putting it all together on your graph paper. We're going to continue to practice with this strategy next week in class, but hopefully this helped for anyone that was struggling with piecewise functions so far. Thank you guys for watching, and have a great day.